Have you ever wondered, what are things made of? Let's take this watermelon for example. We could cut this watermelon in half. And cut it again in half. And again, and again, and again. If you try to cut or divide any object, like this watermelon, you'll reach a point you can't further divide it. Is this the smallest possible piece of watermelon? Actually, it's not. This tiny piece contains a large number of small particles called atoms. Atoms are the smallest particles you can imagine. Just like bricks together make up a building, atoms together are the building blocks of all matter. When were atoms discovered, and by whom? The concept of atoms was first thought of by philosophers in ancient India, around 500 BC. Then, in 400 BC, Democritus, an ancient Greek philosopher, claimed that everything is made up of small particles that cannot be seen by the human eye. He called these particles atoms. Atom means uncuttable. So, Democritus proposed that atoms cannot be cut into smaller pieces. In 1808, an English chemist called John Dalton presented the world with the atomic theory, which stated that all matter is made up of very tiny particles called atoms. What things contain atoms? Everything. Like this bag, pencils, and this paper. Everything that is naturally found in our environment is made up of atoms. Even we humans are made up of atoms. How small is an atom? Atoms are smaller than anything you could compare them with. For example, this grain of sand contains 1 trillion atoms. That is, there are 10 to the power of 23 atoms in each grain of sand. So can you imagine how many atoms there might be on this beach? Atoms are so small that they aren't visible to the human eye. So how do we know they exist? Well, we know that atoms exist because modern-day scientists have invented powerful instruments, such as the scanning tunneling microscope, which can magnify matter several billion times. Here, you can see magnified gold atoms. What is the size of this atom? To see the atom, the gold coin had to be magnified several thousand times. The radius of this atom is 0.1442 nanometers. 1 meter is 10 to the power of 9 nanometers. That means it is 0.0000001442 millimeters small. All matter is composed of atoms. Are atoms in different forms of matter the same? Actually, they are not. Dalton found that atoms of an element look the same. However, the atoms of different elements are different. For example, the tin atoms here look the same, but they look very different from the nitrogen atom. How is each element represented? Just like you identify each of your friends with his or her name, each element can be identified with a symbol. The symbol of an element is also used as the symbol of an atom of that element. Let's let's find out what are the symbols of atoms of different elements. For some elements, their first letter is used as the symbol. For example, H is used for hydrogen and I is used for iodine. For some other elements, the first two letters are used as symbols. For example, Al is used for aluminium and He is used for helium. Some symbols are made from the first letter, which is a capital, and any other letter from the name of the element, given in lowercase. For example, Cl is used for chlorine, and Zn is used for zinc. And finally, some symbols are derived from the Latin word used for the element. For example, Fe, derived from the Latin ferrum, is the symbol for iron, and sodium is Na, from the word natrium. That answers some important questions about atoms when they were discovered, how small they really are, and how they are represented as symbols. Can you think of questions of your own on these tiny, tiny particles?